I'm ready if you guys are.
I think we are.
Oh, we are ready.
We are ready.
I'm just saving some. I'm just uploading things onto the shared folder so that you guys can access to what I'm okay. Let me share my screen. Can you see my screen?
Yes. Yes.
Yeah. So what I've done is I've uploaded content that you see, which is titled Exploratory Geospatial Data Analysis. So in this content, there is the Jupyter notebook, and then there are some. So what you see is, so you can see. So what you see is this is the directory structure. So when you unzip, so if you zip the image folder and the ZWE ADM directory, it should create these two directories, and then you need the Zim Census 2012 Excel and CSV spread, CSV and the spreadsheet. So that's the directory structure, because the file this one, the Jupyter Notebook makes reference to the images in the IMG directory. So it's important that those for you to be able to use the notebook. So what I need you guys to focus on now is just the presentation, and then what we can then do is you guys can then start installing the application, and you then run it on your own to make sure that you can run the notebook, right? Is that okay?
Okay.
Yes, Doctor.
Yeah. So the content is here already. So it's been shared already, right? So it's been shared. So all of that is shared. Right. Okay. So let's start and talk about exploratory geospatial data. So we look at what is geospatial data, types of geospatial data, what kinds of geospatial data is available, and where to get it, right? So what is geospatial data? So the word geospatial is used to indicate that data as a geographic component to it. This means that the records in a data set have location information tied to them, such as geographic data in the form of coordinates. So there could be GPS coordinates, there could be longitude and latitude coordinates, the name of a city, or in certain countries they use postcodes, or in America they call them zip codes, right? GIS data is a form of geospatial data. Other geospatial data can originate from GPS data, such as satellite imagery and geotagging. Right. So I'll show you what we've done with the application that we've developed for geospatial. Why geospatial data is important, and what we've done in terms of developing a geospatial. But this gives you a background so that you understand geospatial data. Right. Okay. Is it clear, everyone?
Yes. Yes, sir.
Okay. So in terms of geospatial data, you've got basically two levels, right, of geospatial data. So you've got what we call a vector or polygon data, right? So your vector or polygon data is a representation of the world using points, lines, and polygons. So vector models are useful for storing data that has discrete boundaries, such as country borders, land parcels, and streets. So common formats are what are called shapefiles, GeoJSON, KML, which stands for Keyhole Markup Language. So often used by data scientists to calculate additional variables such as distance to water, in this example, or weight attributes based on area or density. So basically, vector or polygon data looks like this, right? So it's just an outline of boundaries, right? And those outline of boundaries just cover the boundaries of either of a location or of fields or of a town and land usage. Yeah, is this clear? So this is an example of vector or polygon data. Yeah. So then we've got raster data. So rasters are digital aerial photographs, imagery from satellites, digital pictures, or even scanned maps. Common formats are JPEG, TIFF, GIF, or similar formats. So they help answer fuzzy questions like how many fields were planted in a country X versus which were left fallow. So this ends up being an image recognition type of problem as you're trying to look at planted versus fallow by allocation. So this is what a raster image looks like. So a raster image is more detailed than a vector image, because a raster image shows land usage and elevation. Yeah, is this clear?
Yes, sir.
Right. So what kinds of geospatial data is available online? So you've got administrative data. There's coastal line roads, places, natural features, points of interest, and geospatial data about our water bodies in Zimbabwe. So if I click on Zim Geospatial data, it will take me to this website where I can download administrative coastal line roads, places, natural features, points of interest, and water. You find I've already shared that data with you guys on Google Classroom. So all of this, so your notebook will be exactly the same. So to set up the file that I've shared with you, this one was ZWE_admin zip file. So you just unzip the file which contains the shape files, right? So which is this, right? This one, this one. Right, this one. So it's got all of these files. Right. Is that okay? So when you then unzip it, it will then create this ZWE.admin folder. Yeah. So what we're going to do? Isn't you guys? You did pandas, isn't it? Yeah,
Yes,
guys.
sir.
Yeah, you did pandas, right?
Yes. Yes, sir.
Yeah.
Yes.
So for geospatial, for dealing with geospatial data, there is what is called geopandas. So geopandas is the equivalent of pandas, but it's meant for geospatial data. So GeoPandas is for geospatial data. Right? Yeah. So what we're going to do, guys, is I don't expect you to. I'm just going to walk you through this. What I've done, right? And then after I finish the presentation, then you guys can then set up your environment to see whether you can run the notebook. Yeah, is that okay? Then we make sure that everyone is able to, instead of whilst I'm doing the presentation, everyone is trying to run the notebook. So it's easier if I walk you through it. So all the instructions are here in terms of what you need to install. I've made it quite detailed. So GeoPandas library can read almost all vector-based spatial data, including Esri shapefiles, GeoJSON files, and much more. So you can run this. So for example, right. So for example, if within my folder I've got a file called ZWE admin2. Then I call GeoPandas to read the file, right? And then I call it ZimGeo, right? When I run that, if I then say columns, and it will then tell me if you recall, columns gives you what are the features, right? Or what are the columns within the data, right? And then if I say geo zim.head, so let me actually run it. Right? Right? Then if I say zimgeo.head, and then it will give me information what that is contained in the shapefile. So you can see in this shapefile, I've got the name, right? The ID, right? ID 1, ID 2, name 2, type 2, and so on. Then I've got polygon, right? So polygon is just longitude and latitude coordinates of here, like this, of a vector, right? Is that clear? So if I come here, it gives me the polygon, which are just a series of longitude and latitude points. So let me give you an example. Let me go to the whiteboard. Okay. Let me grab this. All right. So let's say this is so let's say this is my my map, right? This is the right. This is my map. So here is one point with longitude and latitude, right? Then I can define another point here, longitude and latitude, right? And this other point, right? And then this point. Then this point, maybe this point, this point, that point, that point, that point, that point, and so on. So all of these points are right. So all of these points form the polygon, right? So polygon means just many. Poly means many, right? Yeah. So then this gives us our vector of polygons with all the points, right? So if I go back to there you go. If I go back to just, so this is what you see here in polygon, all these different points. So it gives you the points of the shape of the. It could be a town, it could be a field, for example. It could be a field like this, or it could be anything, right? Yeah. Is Wellington on this? Wellington Reviewer, is he on this call? Wellington or Gondo? Shakshedu Gondo is not on this call. It's not on this presentation. No, they're not. Okay, it's fine. So I'll show you where these things are useful and where they can be applied. So we've did an application for it's especially useful for remote sensing. So by remote sensing, so what guys normally do in the agricultural sector, especially those that do contract farming and so on, they'll give a farmer a contract to go and farm. It could be maize, it could be tobacco, and so on, right? So when they're given a contract, they want to make sure that the farmer performs, right? So this same concept applies to command agriculture as well. And presidential input scheme, and there's also Pumvudza. Yeah. So the biggest challenge is now, how do you monitor those particular fields, right, to make sure that the loan that you give and the farmer, they'll be able to pay back their money, right? They'll be able to pay back the money that they owe. It could be the bank, it could be the government, or it could be anyone else. So this is where the issue of vectorization is important, and longitude and latitude coordinates and GPS coordinates, because you only be able to mark a particular field. For example, it could be a field of chibage or a field of wheat or whatever crop it is. Then you want to be able to monitor that this particular crop is performing well, and then the farmer is highly likely going to be able to pay back their loan, right? So that's part of geospatial analysis using satellite images. So I'll give you I'll show you an example, and then I'll continue. Let me just stop this and set it up 1 second. Okay, I'm done. So let me tell you what the challenge is, especially with Zimbabwe is largely an agricultural based economy. Yes, we've got mining, but majority of our GDP contribution is actually from mining. Only constitutes about 25% of GDP, right? If there are any economists, you can correct me. And then agriculture actually constitutes quite the biggest component of GDP. Therefore, growing our agricultural sector will only enhance our GDP. So the biggest issue, the problem that I was trying to solve was, for example, if you give a farmer a loan, right, to plant a field, it could be wheat or maize. You want to be able to make sure that the farmer performs because of the associated risks with farming. It could be weather, it could be dry, it could be anything related to weather or lack of farming skills and so on. So normally what happens, they've got what they call field officers. So field officers go, or agronomists, they go and visit the farmer and they look at the fields, and then they determine, and then they do a soil test, and then they determine what inputs that the farmer needs to say you need so many quantities of, so your bill of quantities for fertilizer, for seeds, for chemicals, and fuel for the tractor and so on. Yeah. So then after the farmer then plants based on the bill of quantities that they've agreed upon with agronomists, then obviously then they are what we call monitoring and evaluation agents. So the monitoring and evaluation agents are there to monitor that the farmer is actually planted, they haven't sowed the seeds or they haven't eaten the seeds, right? And they've actually grown the crop, and now the crop is actually germinating from the ground. And then there's a process of monitoring the crop up until harvest time, right? So so now imagine if you're dealing, especially with Zimbabwe, we've got A1 farmers, A2 farmers, and so on. So you're dealing with a lot of farmers who under different schemes. So there's Command Agriculture, Presidential Input Scheme, and then there's Pumvudza, and then there is the large-scale commercial farmers who go and get loans from banks who are not under any of the government schemes. So we've got a lot of activity in the agricultural sector, and the biggest risk is actually monitoring those fields to make sure that the farmer performs. Right? So what I basically worked on is what we call remote sensing. So remote sensing uses satellite technology to be able to monitor a field. So basically that's what it is, right? Without putting any sensors on the ground. So it will monitor the soil, it will monitor the field in terms of the dew, precipitation, and I'll explain other terms like NDVI, EVI, and so on. That's the remote sensing we'll look at. It will look at soil moisture. It will look at pH of the soil and other detailed information to determine whether the crop will actually do well. Right? So now imagine trying to do that with a team of agronomists, and you've got over, so the program has got about 400,000 farmers. Right? So a single agronomist can probably do, maybe in a good crop season, can cover at the most 1,000 farmers, at the most, and not more than that. So therefore, it becomes very difficult to monitor those fields, and therefore it's important then to so therefore it was important to solve the problem of this is a scale and capacity issue. You will need to be able to have technology that can monitor all of those fields at once for all the 400,000 farmers plus. At the same time, you want to be able to look at each field, how well it's performing, and then drill down to say, are we going to is the farmer going to be able to pay back, or are they going to be able to make a loss? And you also want to intervene early before the crop starts, when you notice that the crop is stressed, so that you can then intervene early and tell the farmer, no, the crop is stressed. Can you please, apply this chemical so that you are on track to getting your expected yield. Right? So what we did. So basically, let me show you. I'm forgetting that. Right. Stop sharing my screen, so that you guys understand the importance of. Right. You can see my screen, yes?
Yes, can see it.
Yes, sir.
Yeah. So this is a so this is the application that we developed. So let me show. So let me drill down. So this is Harare. Right. So you can see. So it's giving me. Remember, we spoke about. If I go up here, we spoke about raster data, and then we also spoke about vector data, right?
Yes.
So yeah. So at the moment, this is a raster data. Raster data. Where are we? We're in the area of Maslowe, right? Right. So from this, you can actually see. You can actually see the fields, right?
Mm-hmm.
Yes. Right. You can actually see the fields, right? Yes. So what we do, right? We identify, for example, a farmer will give us his address. When he gives us his address, for example, here we can enter, for example, Mazoe, and then we can then search, right, and then drill down to their particular field, right? Yeah, can you see? This is a farm which has got center pivots, yeah? Yeah? Yes, you can see it, yes?
Yes, we can see
Yes.
that.
Yeah,
Yes.
so what we then do is we mark the field, right? So how we mark the field is we do this. So we create we mark the longitude and latitude points within the field so that we can pick out the field. So in this instance, I'll mark here, right? I'll mark here, I'll mark here, right? I'll mark here, 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 right? Just following along the contours of the field, right? Right? So if I'm now done, right? I've completely marked the whole, can you see I've completely marked the whole field. And then after I've completely marked the whole field, I can then give it a name, right? I can say farm _1, right? And then I can then export, right? So what that will do is if I open this up can you see this?
Yes.
You see it's got longitude and latitude coordinates.
You can't read the text.
Okay, let me think it's all right. So I made it quiet. Can you read the text now? Right. So this text is in JSON format, and what you see is here it says coordinates, right? So you see this longitude and latitude coordinates that we're marking, yeah, for that particular field, yeah. Yes, you can see that, right? So after marking,
yes, we can.
Yeah. So after marking those coordinates, it forms the polygon of the field, right? So what we then do is then we upload that data we upload that data to a satellite, right? So what is called so we upload that data to a Sentinel-2 infrared satellite. So it's a Sentinel-2 infrared satellite. So what that satellite will do is it will look at the coordinates and then it will scan. The field. So it will scan the field. All right. So what that looks like is something like let's see what that looks like. The field that we've marked. Where is this field? So there's many of these fields that we've marked. Right. So let's say for example this. So what we then do after we've marked, we can then say what is the and then it will give me just for that particular field. It will then give me the weather, right, for that particular field. So right, I can have the rainfall pattern for that particular field. Yeah, and then it will give me and even a forecast for the next 2 weeks for that particular field, right? Then I can also look at soil data, right? So the soil data will give me what is the the moisture, what is the pH, and so on, so that we know how well the crop can perform on that particular field. Yeah. So what we also do is from the satellite imagery, it has what we create what we call NDVI. So it takes a bit of time to load the whole field. So what happens is the NDVI stands for Normalized Differential Vegetation Index. So if let me show you what that looks like. Yeah, so it looks it looks something like this. Yeah, it looks exactly like this. So what this basically is if you use infrared light, so we use infrared light. So what infrared light contains red, green, and blue spectrum of light. So if a plant is healthy, it has got more chlorophyll content. So therefore, it is more green, right? So what that means, when you shine infrared on it from a satellite, it will absorb the red and blue spectrum of light and reflect the green, right? So if a plant is stressed, it means it's less green. So what that means is it will absorb the green and reflect the red and the blue spectrum of light. So this is the type of image that you get. So you can actually see the parts in red mean that the plant is stressed, right? And the parts in green means the crop is doing well. So this is a number. So with this type of image, you can actually see the whole crop is doing well. And with this example, you can actually see this example, the parts in blue, you can actually see that the plant, the crop is stressed, and everything in green, the plant is doing well. So based on this, you create what we call an early warning system for the farmer, where it picks out all the areas that are stressed and it tells them now to apply a particular chemical or process to revive that particular section of the field, right? Yeah. So let me show. So therefore, we then based on that, we created a dashboard. So basically, what the dashboard does, it monitors every field, right, on every farm. So here's the farm name. You just search for it, and then it gives you all the information that you were saying. It will give you the rainfall, so it's basically an agro monitoring dashboard for each field, and then it creates alerts for the farmer. So these are the farms that you were seeing that were sent to the satellite. So the process takes a bit of time to upload the coordinates to the satellite, then it starts scanning. So that process takes about an hour. And this is why I'm jumping to show you what the output actually looks like, right? So this is an example of an application of geospatial data analysis. Right. So with this, I can monitor every single field in Zimbabwe, every single crop in Zimbabwe. And not only that, I can also calculate what is the expected yield for maize for the whole country. I can calculate what is the expected yield for wheat for the whole country at the click of a button, right? To try and do that will take at least 100,000 people over a year to do it. But I can just do it at the click of a button, and I've got all that information at my fingertips, right? Yeah. So this just shows you that data analysis works, right? This is showing you a real life example. So when we're talking of geospatial data. This is an example of how I apply geospatial data to actually solve a real life a problem. So going back to the lecture, we spoke about vector and raster images, and then we spoke about GeoPandas. So I imported the shape file, and then we can see the data and the polygon, so you guys understand why we need a polygon. So basically, the shape file just gives me the outline of a particular city, in this case, it's a district, right? So these are outlines of contours of districts in Zimbabwe. So that's all that is it is giving me. So then I can look at what are the unique names, right, of those districts, so Bulawayo, Harare, Manicaland, Mashonaland Central, and so on. And I can see how many are they? They're about 60, right? So what I can then do is I can use GeoPandas, for example, to then plot. So I want to plot the same way we're doing a visualization. So now I actually want to visualize what these districts look like, right? So what I can do is then I can then use remember here I'd imported my data using GeoPandas and called it ZimGeo, right? And then after that, I can now list, right? So what basically this is, I'm now plotting the Yes, can you see my screen?
Yes, we can see it.
Yes, you can see the Zimbabwean map.
Sorry?
You can see the two Zimbabwean maps.
Yeah, so you can see the map, Zimbabwe map. So you can see here that I've got all the districts, right, colored in different colors. Yes. So this is Matebeleland, this is Mashonaland West, and so on. Yes. So based on the this is the legend, right? So the here is showing. So this is Bulawayo, Harare, Manicaland, and so on. Yeah. Yes, guys.
Yes, sir. Yes.
Yeah.
Yes.
So what you can also do is you can also convert a vector map to real world. So what real world means is you're converting this to actual. So this shows you so this is a vector map showing you all of the boundaries. But you want to be able to convert it to real world. By real world, we mean that you want to be able to see the streets, the cities, the towns, and other information. So that's what we mean by converting to real world. So what map a leaflet does is it converts a vector map to real world map. Right. So this is what it does. All right. What is this doing now? Yeah. Now this is giving me an error because of that's it. So all right. Okay. I didn't run a cell. So you can see it's giving me the same information. But now the difference is now giving me the real world, what it looks like with all the names actually on the map. And I can actually zoom into this and actually see more detailed information, right? Yeah, so this is, so you can then convert vector to real world, and you can also convert raster to image to real world, right? Yeah. So is this clear?
Clear, sir.
Yeah. And then I can also plot districts, right? Just the districts. And then you can see here, here now I have Beit Beach, Bikita, Bindura, Binga, all of the districts of Zimbabwe. So this is the legend for it, right? Right, and then I can then take the district map and also convert it to real world. And then you see it's the same map, but now this is the real world version, but with using the same colors to differentiate each district that it had used on the vector map, right? Then what I can also do is how many districts are there? There are 60 districts. I can, for example, slice and dice geospatial data. So I can select Rishawane only. So in this instance, I say Rishawane is equal to ZimGeo. And then I remember the filtering process. I filter, and then I say I want Rishawane only. And then in this instance, it then gives me Rishawane. Yes?
Yes, sir.
I have a question there.
Yes.
That function which converts the vector to a real world image, how does it really work? Does it communicate with the satellites? How does it work?
So it's using Google Maps. So it's using it's using Google. So it's basically using Google. So in this case, it's using Leaflet. It's using OpenStreetMap. Sorry, it's using Leaflet OpenStreetMap, right? Which is similar to what Google Earth does, right? And you can then actually drill down into the particular map, a real world map. So basically what it does, it goes into an actual map that is labeled with names and so on, and it takes the colors that have been applied to the vector map and imposes that on the real world, right? And then it fetches all the data within that real world vector and converts the vector map to real world with all of the coordinates that are specified in the vector and the vector map.
All right. Okay. Thanks.
Right.
Hello?
So yeah.
So just out of curiosity, if I'm not connecting to the internet, will that shape after I've applied the leaflet come out the same, or it will give me an error?
No, remember, it's sorry. This is actually taking it from the internet, but you don't have to necessarily take it from the internet if you've got a GIS package with all the map, the real world map details. You can actually connect to a GIS application like Esri, for example, and it will give you it will do exactly the same. But in this instance, I'm using OpenStreetMap through the map, the leaflet API, which is connected to obviously to the internet.
Okay.
Yeah, is that making sense?
Yes, it does. It does.
Yeah, and then so we're talking about Rishawane, and then in this instance, I can then select Rishawane. You see, then it gives me Rishawane only. Yeah. So now I'm now slicing and dicing geospatial data. Yeah.
Yeah, it's clear.
It's clear. Yeah. Yeah. So that you guys, you see, actually this works. So I can then also just select Mashonaland West, right? And then Mashonaland West is composed of Chekutu, Urungwe, Kadoma, Kariba, Makonde, and Jimba, right? Yes? And then I can get the real world vector. Then I can do vector to real world. And then you can see it is marked Mashonaland West. Yeah? So what? Yeah. So what you want to be? So what you want to be able? So a simple application. I've got the census data. So the census data. So if we read the census data, it simply has the name, the district, right, and the population for that particular district. Yeah, that's all. So this is from Central Statistics Office. So the name, the district, and the population for that particular district, right? Yeah. So for example, Harare is 2.1 whatever million. Uera is 245,000. Yeah. As of the census of 2012. Yeah. So what I want to be able to do is I want to be able to take the census data, which is named by district, and be able to show the difference in the population sizes on the map as a visualization, right? So to do that, I read my census data. After I read my census data, there's no need to. What I will then do is I will select my from my census. I'm taking the name, right, and then I'm matching the name, right. So what I then do is I match the name from the census data to the name which is on the geospatial data that I've mapped, that I've imported, and match those two, right? So that's what basically I'm doing here. So I'm creating a join of the two, right? An inner join of the two, right? So after then I've created the inner join of the two. Now I've got there I can then show you here. So now I have my census. I now have the other information that we're seeing up there for the map that we've imported. Now I've appended, right, the population, right? So we can see for Bulilima district, it's that's the population. So what I can then do is I can then drop irrelevant columns, and then I can also drop columns that are irrelevant. Then I can then take the map, and then it will then show me all the population. Then it will give me a color coordinate to show me what for each area the population size, right? So in this case, so I've combined population data, right, which was labeled, which only had the name of the district, which only had the name of the district, and then I've now added the population data. So now this is what it looks like, right? And then I can then do the real world. That will take time to send that data to thing. It takes a bit of time. So this gives you an example of geospatial data analysis, right? It's not that difficult, right? I can also show you. I showed you one application, which was the field, the remote sensing of the field, right? And then here I'm showing you how you then do visualization to combine that with other data, right? Yeah. So it's almost 8 o'clock. So let me show you another application. 1 second. Let me show you another application. Let me just check.
Hello, Doc.
Yes.
There have been some talk on the exam. Is this practical or is this theory?
So the way your exam is structured, right? The way your course is structured, it's 75% practical and 25% exam. So exam is theory, right? Are we together on this one? The exam is theory. And then your 75% is you do projects, right? Yeah? You are given projects to do, 2 projects, right? One is a group project and one is an individual project, right? So the group project is worth 40% of the mark, and then the individual project is worth 35% to make a total of 75. Yeah, is this clear? So that project you are given 2 weeks to do. Those 2 projects you are given 2 weeks to do. So it's almost like it's an open book exam that you do to show that you can apply. Yeah?
Yes, what about the theory exam? Will it be open book as well?
Of course not. Of course not. It's only 25%, and you want it to be open book, and yet the 75% is open. Come on. I mean, how generous can I be? So I should just give you 100% without you writing the exam, right?
It was just a question. Thank you.
I know, but so the whole point of this course is to demonstrate that you actually have learned and you can apply.
Okay, thank you.
All right, so let me show you another quick one application. Yeah, all right, so all right, so let me show you what I did, so you can Google some of this work that I did for. So this was Cyclone Idai. So if you recall Cyclone Idai, so let me show you what I did Cyclone Idai. There's no need for that anymore. So with Cyclone Idai, what I was doing is I think it's the first cyclone that we actually experienced in the past 100 years, right? So no one had experience in dealing with cyclones in Zimbabwe. So my job was to simply track the satellite. So what I got from NASA was they were giving me the position, the longitude and latitude, and the intensity of the cyclone in knots, right? So this is the data that I got from NASA. So you can see this is a particular time. This is the longitude, latitude, and this is the speed intensity, right, measured in knots. So then what I then did is that then I converted that to so I converted this time to proper time so that we can read the date and the time, and then converting knots to kilometers per hour, you multiply by 1.82. So this is what I then did to convert, and then this is what I then got, right? And then now this is now the speed of the cyclone in kilometers per hour. So you can see this is the so what I then did is I took the longitude and latitude points to then create a tuple. So basically I'm taking is the longitude, latitude, and then so that I can plot the path of cyclone Idai and then be able to predict the path of cyclone Idai, right? Yeah. So I then after that, you can see now I now have the geometry of each point, which I've put created a geospatial data frame, right? And then from there, what I then did is I did same thing, right? Took the map, right? And then what I then did on the map is then I was just only in the world map. I was just only interested in Africa. And then here I took Africa. And then from Africa, we knew that cyclone Idai was coming from Madagascar, going to through Moses, going to come through the Indian Ocean, and then through the coast of Mozambique, near Beira, and then coming to Zimbabwe. So the countries of interest for me to be able to create my model are obviously Madagascar, Zimbabwe, and the Indian Ocean, right? So therefore, I then select only the countries which are Mozambique, Zimbabwe, and Madagascar, right? And then from there, you can see I then created, this is Zimbabwe, Mozambique, and Madagascar. And these coordinates points, right, are now what I've now marked in red. So the cyclone started somewhere here, went here, then came along like this. Yeah? Are we together on this one? Then what I then did is I then converted to real world so that we can actually see, right? And drill down. So you can actually see this was the predicted path by NASA. So this is the cyclone. It came like this. And then it then was supposed to pass through. Can you see here? It was supposed to pass through what? Mutare, yes? This is Mutare, yes? And then come like this. Yeah? Can you see?
Yes, we are following, Doc.
You're following, right?
Yes.
Yeah.
Yes.
And then what I then did is that I then plotted at what interval of time are we expecting the highest intensity, and then at what speed that particular intensity will be. So you can see at the particular time that it hits in Beira, the speed was 350 kilometers an hour, right? So at speed of 350 kilometers an hour, the wind can lift a gonyet and throw it 100 meters away. That's how powerful Cyclone Idai was, right? It could lift a whole gonyet and throw it 100 meters right? That's the speed of 350 kilometer winds, right? So you can see this is where it was at its peak and intensity. Right? So what I can then show you is, so what NASA got wrong, right? This is the predicted path of what NASA gave everyone, but this is the actual path that I plotted and predicted, which is the path in red. Yes? Are we together on that one?
Yes.
Yeah.
Yes.
Yes.
Yeah. So you can so based on this map, you can imagine if our government had used the data from NASA and said it and believed it to be correct, right? They just didn't take any action. It means that they would have evacuated people in Mutare, and where would they have evacuated those people to? Just simple logic.
Chimaniman.
Exactly, they would have taken them to Chimaniman, and what would have happened?
And they will all perish.
Exactly, so they would have all.
Total disaster.
Yeah, exactly. So you see here, so me, I was busy then arguing with NASA, obviously telling them, no, look, the predicted path is for Cyclone Idai is wrong. So obviously, I was trying to also educate the Met Department. No one was listening, right? But you can actually see that this is an act of God, because if we had listened to that information, all the people would have perished, right? So this is what actually happened in terms of a cyclone Idai. So let me show you something else which is also quite interesting. So this is their predicted path, which was done by NASA. You can see it's coming here and actually passing through Mutare and coming to Harare, which was wrong. And then let me show you something. So this is the intensity that you saw of the wind in kilometers per hour. And you can see what you see in red is when it hit Beira. And what you see in yellow, the time span when it hit Chimanimani. By the time it got to Harare, the wind speed was around 80 kilometers per hour, but still it was quite powerful to do quite a lot of damage. When it hit Chimanimani, the wind speed was around 180 kilometers per hour. So those winds were powerful. So based on that, what I actually did, I then was tracking the cyclone and then looking at the satellite image every hour, looking at the devastation the cyclone was doing. And then what I was then trying to do is I will look at, for example, a day before and currently now, and then compare the actual damage which was done a day before and then. Let me show you how where is this? Yeah. So I did one for Beira, Mozambique. So what I did is I took real estate data and estimated the value of every single property in Mozambique. And then I looked at, okay, what is the actual damage of the, and then I marked every single building that was damaged in Beira, right? You can see everything in square, everything that you see in square is what was marked. Then I calculated what is the total cost of the damage by the cyclone in terms of physical infrastructure. Obviously, we cannot calculate human cost. It's incalculable. So I calculated the total cost in terms of physical damage. So the cost of the physical damage was 3.2 billion, American dollars. So when they were asking for $50 million from the United Nations, and I was like, but what's the point? The damage is 3.2 billion. Why are you asking for 50 million? What is it going to do, really? I mean, it doesn't actually make any sense. So you can actually see the power and importance of understanding geospatial a data analysis, you can do quite a lot, right? You can do quite a lot. Right?
Hello, Doc.
Yes.
This is quite interesting and very insightful. And when you were speaking to some of these events, I just had two questions.
Yes.
Comparing the data that you received from NASA on the cyclone Idai, I would also want to do an exercise to see what have been the history with such data, possibly using cyclones that have happened in America. Because sometimes I think this would actually indicate that they would prioritize having more insight in other countries than the other. Hence, we end up receiving very, very erroneous data. Then my second question would be using this kind of technology, especially for the agri solution, where you are visualizing the fields and using remote sensing. Is it also not possible to do heat mapping? Let's say there's an accident in a mine. Let's say in Mazoe there was some fatality. Can't we search for survivors using their heat signatures, probably using the infrared as well?
Absolutely, because infrared can go up to 10 kilometers deep in the ground, right? So as long as they are not more than 10 kilometers deep, of which I don't know any mine which is more than 3 kilometers deep underground. Is there? I don't think so.
I think Zimbabwe. No, not in Zimbabwe. In other countries they are.
Yeah, right. So so absolutely, you can actually use that to search for heat signatures and look for survivors underground. Absolutely. So you can the applications are actually endless. Right? So one thing that we were trying to do is look at crime data, of which the government refused to give us crime data. So we can actually mark all the hotspots of crime around Zimbabwe. Then you can actually give people a real-time dashboard to show them where all the crime hotspots are, so that they know which areas to avoid and in which areas to be very vigilant when you're going into those areas, right? So the application is endless. So if you look at also another one is if you think about it, so based on geospatial data analysis, I can take the census year 2012, and then I can take the voters roll, and then I can take my results as ZEC and see whether they are fake or real. Right? You get it, right?
Interesting.
That would be interesting.
Yeah.
That one is good.
Yeah. So
I think I found the project to do.
Sorry?
Okay, I was saying I think I've now found the project to do for my dissertation, the ZEC thing and the census data that you have a result of what was really happening. Was there rigging or something came out properly?
Yeah, but you might disappear, so you have to be careful. Yeah. So you can see the application So me, I was busy laughing.
Just out of
yes. Sorry. Yes.
Okay, maybe just out of interest sake, how do you predict the direction of the cyclone? Like I was just trying to follow through on that one which was given by NASA and the other one which you did. How do you predict the direction of the cyclone? Like the yellow line, so the blue line and the red line.
Yeah, so the way you predict, so remember you've got longitude and latitude position, right? And you've got previous longitude and latitude positions, right? So what you then do is based on that, you then let me show you. So let me do this. So let's say this is the okay. So let's say this is the first last known point, and so let's say I've got 2 points, right, that are last unknown, right? So based on the remember the longitude is a line longitude and latitude, longitude and latitude, right? Can you see?
Yes, I can see.
Right. So I've got the longitude and latitude based on that. So what I can do based on this 2 points, I can calculate the diagonal from here to here, right? Sort of like a straight line.
Yes.
Yeah. So
Yes,
from here, right? Can you see from here? So let's say the other point was somewhere here. So let me just draw this longitude and latitude. Right? Can you see that like that? Right? So based on this, let's say this is north, this is south, this is east, this is west, right? Yeah. So based on this, right? Based on these points, what I then do is I calculate, I interconnect these 2 points, right? Yeah. And then after connecting those 2 points, so I've got a point which is south west connecting to another point which is southwest in a certain degree angle. Yes. So with this one is let's say it's southwest certain, let's say it's 40 degree angle. This one is southwest let's say 50 degree angle, yeah. And then another one would probably be southeast and so on, and then degree of angle. So then I take all of these coordinates, right, and simply use a regression to then determine what the likelihood of the next point be, right? Whether it's going to be south or west 60 degrees or so. And then I then use that as my next longitude and latitude. And then I connect it to the previous point. Yeah, does that answer your question?
Yes. Thank you so much. Yes, I'm answered.
Yeah. Yeah. So geospatial analysis, you can do a lot. So I think what you guys are supposed to do now is based on the notebook, what you're supposed to do, which we'll look at tomorrow. So you need to run this notebook on your own, following the instructions. So all you need to do is you need to install GeoPandas, you need to install Map Leaflet, and you need to install Descartes. Right? Those are the only 3 packages, and the instructions are here. It's not difficult. Then you're able to run and do all of these things. Yeah. Yes. Yes, guys.
Yes.
Yeah. So that's it, guys. So that's it. At least from there you can actually look at. So you can actually take other data, which is not census data. It could be maybe you work for a particular bank or insurance company or whatever. You've got data of your customers and their addresses, and you want to plot that on a map. So you can actually use that to do that, right? Yeah, and you actually want to see the distribution of your customers and the concentration on the map. So you can actually do things like that.
Hello, Doc.
Yes.
So let's say I have a data set of my customers, and I want to see how they're distributed around Zimbabwe. So I wanted to plot, let's say, a scatter plot of my individual customers. Like, okay, a very practical one is we are currently doing an assignment where we are mining Twitter data, right? So now I want to take the comments and the locations of the people who commented on a particular subject, and then plot those comments on the map. But I want the map to then show me dots. Let's say someone tweeted from Harare, then it should plot a dot in Harare, a dot in Blawayo if someone tweeted from Blawayo or something like that.
Yeah. Okay. So what are you using the Twitter API, the developer API?
Yes, I'm using that.
Yeah. The Twitter developer API is actually giving you location information.
Yes, it does. It gives me, I can't remember, but it gives me some location. It should be names of the town from which the person is tweeting from. Let me see if I can find on my laptop and verify what I'm getting from.
Yeah. So with Twitter, if you've noticed, it's got several levels of subscription. And one of them that I know, the developer one, you don't get the full data set, you get sampled data, which is quite restricted. And then if you are subscribed, you get there are different levels of subscription. And then depending on the level of subscription, you get now much more information.
It gives me the country code, it gives me the geo coordinates, it gives me the BB coordinates, and then the location. And then the country. It gives me a whole lot of
Yeah, so it's quite simple. Yeah, so you remember what I did with Cyclone Idai data, right? So with Cyclone Idai, I've got the same information that you've got, right? Yeah. Longitude, latitude, yes.
Yes.
Yeah, in this case, I've got intensity, and you've got the tweet, right?
Yes.
Yeah, so you can then do exactly the same. And you create your, you take your longitude and latitude points, and then you create a tuple, right? And then you put that tuple into a GeoPandas geospatial data frame, right? And then once you've got those points, you can now plot those points. You then select the map of Zimbabwe, and then superimpose those points onto your vector image. Then you convert vector to a real world image, and then you see all your customers, and that's it. Over. It's not difficult. Yeah, I'm showing you. Yeah, so that's
interesting. Yeah.
5-minute job, that one.
Yeah.
So you can actually do a lot. So there's a lot of stuff that I can't show you for confidentiality reasons that I can't show you. Otherwise, I'll disappear. So there's a lot of other stuff that I can't show you, right? That you can do this stuff. Yeah, let me just leave it at that. Yeah, but you can see it's quite powerful, right? Yeah. So anyway, guys. So can you please do what we've agreed, that you run this on your own, and then you can take some data, regarding whatever information to do with Zimbabwe, and then you can actually plot it for yourself and see, right? Yeah?
Yes, sir.
Yeah, so that's it, guys. That's Geospatial data analysis. So at least now you know how to do structured data, you know how to do image, and you know how to do special data. So these are the three categories of data. So everything else, we've covered all the structured, semi-structured, and unstructured data. So that's it. We're done on EDA. Are we okay, guys? So that I can leave you at least to get your hands dirty. The information you have is already uploaded. So what would be interesting to see what you are able to come up with, right? So we can actually do that at the end of the week with some of the ideas you are talking about of heat and so on. Let's see what you guys are able to come up with. Right.
Thank you.
All right, guys. So thank you, guys. So I hope this was insightful.
Thank you, Doc. Thank you, Doc.
Thanks, Doc.
All right.